probably wouldn't either, considering it's huge.
Okay, today we're looking at doing some curve sketching, and we're going to use the first and second derivatives to help us get a good idea of what the curve looks like, and we're going to use all of the information to sketch the curve as best we can. Okay, we're going to do 2 examples together, and then you'll have 4 problems to work on your own. So, let's get started. The first one that we want to look at is y equals 3x to the 2/3 minus 2x plus 2. This is the first curve we want to sketch. Now, why do we want to use the first and second derivatives? What can they tell us?
Cavity,
increasing, decreasing,
relative
extrema, critical points,
and something else.
points of inflection, and so on. All right, that's what we're looking for. So, first thing we want to do to our function is what?
Take the derivative.
Take the derivative. All right, so 3x to the 2/3. I need to bring that 2/3 down. What happens when I bring the 2/3 down?
The 3's cancel.
3's cancel, leaves me with 2. I subtract 1, so now my exponent is
Negative 1/3.
-1/3. The derivative of negative 2x is negative 2, and the derivative of 2 is 0. All right, and while we're here, it's best to go ahead and get your second derivative. So my second derivative, I bring the negative 1/3 down. Gives me negative 2/3. I subtract 1 from my exponent, and that gives me negative 4/3, and then the derivative of negative 2 is 0. All right, then what do I want to do to both of these?
Set them equal. No.
Set them equal to 0, and while I'm doing that, what else should I do? What do I do with my negative exponents?
Put on the bottom.
Move them on the bottom. So this would be the cube root of x right there. And this would be negative 2 over 3 times the cube root of x to the 4th there. Okay, on this first derivative, what's the best thing to do to that?
To find the
Find
Okay.
zeros.
Right, what's the best thing to do to help me find the zeros? I can get a common denominator. So I'm going to multiply this 2 by the cube root of x. And then we're over the cube root of x. I recommend that if you have a fraction, plus or minus something else, get a common denominator and turn it into one fraction. And then I set the top equal to 0 and the bottom equal to 0. Alright, so in the top, let's add that 2 cube root of x over. Divide both sides by 2, which gives me 1, and then what do I do to finish up?
Cube root.
Don't take the cube root.
Cube 1.
Cube both sides, so I end up getting x equals 1 there. And what do I get on this other one?
0.
I get x equals 0. Alright, so that's for the first derivative. On the second derivative, I have no variable in the top, so can I get anything out of the top?
No.
No, so I set the bottom equal to 0. And again, what's going to make that equal to 0?
0.
0 will. So, on my first derivative, I'm looking at 0 and 1. On my second derivative, I'm just looking at 0. Alright. So, number line, I've got 0. I've got 1. On the left side of 0, what's a good number to plug in on the left side of 0? Negative 1. So if I plug negative 1 in, that makes this positive. So my top's positive, my bottom is negative. So that means that's going to be negative. Okay, what's a good number to plug in between 0 and 1?
1.5. For
I would want to plug in something that I can take the cube root of. What's the number between 0 and 1 I can take the cube root of? is what I'm thinking of. Yes, 1/8.
Oh,
Oh,
Okay, the bottom I don't have to worry about. The bottom's obviously going to be positive. But what's the cube root of 1/8? 1/2, and then 2 times 1/2, 1. So this would be 2 minus 1 on the top, which gives me positive. So that section is positive. Then what's a number bigger than 1 that I can take the cube root of?
okay.
8.
8.
So the bottom is obviously going to be positive. On the top, the cube root of 8 is 2, and 2 times 2 is 4. So I've got 2 minus 4, which means the top is negative. So, what do I have at 0? I have a relative min at 0. And at 1, I have what? I have a relative max at 1. Now, since we're graphing them, we need the y values to go with them. So how do I find y value? Plug it into the original. So I plug in 0 into the original, and it gives me 2. I plug 1 into the original, so that would be 3 minus 2 plus 2. That gives me 3. All right, now we go to the second derivative. My only number is 0. What will my denominator always be in that second derivative? It will always be positive. How do I know that? It's to the fourth. So my denominator is always positive, but my numerator is always negative. So that means both sides are negative, which means my graph is always concave down. All right. All right. So we want to start with 0, 2. So I have 0, 2. Which is right there. I have 1, 3, which we'll put as right there. All right. Now, once I figure out what my max is, what my min is, and my points of inflection, we always want to put in an extra number on the right and an extra number on the left. So what's the number I can put in on the right?
2.
2. So we want to find y of 2. So I plug in 2. Actually, is 2 going to be a good number to plug in? Because I need something squared that's a cube root. What is something squared that can be a cube root?
64.
64 is a cube root.
Not cube root.
Can I square something to get 64?
8.
8. So let's plug in 8. So if I plug in 8, 8 squared is 64. The cube root of 64 is 4. 4 times 3 is 12. So I've got 12 right there. I plug in 8 here, gives me minus 16. So this is negative 4 plus 2, so I end up with negative 2. Okay, on the left side, what's a good number to plug in on the left side? Negative 1 is nice and easy on the left side. So negative 1, if I square it, gives me 1. The cube root is 1, so that would be 3. This turns into plus 2. So 3 plus 2 is 5, plus 2 is 7. So negative 1, 7. And so we'll just put that up here somewhere. And then 8, negative 2. So 8, negative 2 down here somewhere. So with that information, along with my concavity, we should be able to figure it out. What did we say our concavity was?
Concave down.
It was always concave down. So on the left, when I connect these two dots, what do I have to make sure of?
It's concave down.
That it's concave down. So I need a little bit of an arc there. And then on the right, everything needs to be concave down. So I'm going to connect those like that. So you want to find your maxes and mins, your points of inflection. Pick an extra point on the left, an extra point on the right. Connect everything the way it should be connected. Then you want to go to your calculator and graph them and see if we got it right. And this is what the graph looks like on the calculator. Does that match what we
Yes, it does.
have? Questions on that? Jasmine, question? Okay, so again, what do we do on this one? What was our process?
Find first derivative.
First and second derivative.
Set them equal to 0.
Set them equal to 0. Use the first derivative to find
Increasing and decreasing.
Increasing and decreasing, and more importantly, the mins and maxes. Use the second derivative to find concavity. Okay, I need y values to go with those points. Once I get those plotted, I need an extra point on the left, an extra point on the right, and then connect them all using the concavity we said. So that's what we're looking at on that problem. Question? All right, let's do one more. On this one I have f of x equals 5 minus 3x over x minus 2. What's something I might want to do differently to start out with on this one than I did the first one? What's something that this one might have that the first one didn't? This one has asymptotes. Where are the asymptotes?
Two.
-3.
At, I've got a vertical asymptote at x equals 2, and what you say, Jasmine?
-3.
And a horizontal asymptote at y equals -3. Explain how you got the -3.
I've looked at the x's and they have the same exponent value, so I just took the coefficient.
Very good. So the x's are the same power, and if they're the same power, then I take the coefficients to get my horizontal asymptote. That's where we got -3 from. What happens if the exponent of the bottom is bigger than the top?
Zero.
It's 0. What happens if the exponent of the top is bigger than the bottom? There is no horizontal asymptote. Good. Any questions on those asymptotes? Anytime you're dealing with what type of function is this? What's the name of this type of function?
Fraction.
What are those called if they're fractions? Rational function. So when I've got a rational function, what's the first thing I should do? Find vertical asymptotes and horizontal asymptotes if they exist. All right. Once I do that, then everything else is the same. I need to find the first derivative. What's required to get the first derivative? Quotient rule. So that would be the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Distribute in the numerator. So that is -3x plus 6 minus 5 plus 3x over x minus 2 squared. So my numerator ends up being what?
Negative. No, just one.
Just 1 over x minus 2 squared. So I know it's just 1. Alright, what can I do to make it easier to find my second derivative?
Put the bottom of the top.
Move the bottom to the top, and when do I know to do that?
Negative. When there's no variable.
When there's no variable in the numerator. Good. So before I find the second derivative, let's move it to the top, and then find the second derivative. So that would be -2, that would be x minus 2 to the -3. So that means my second derivative is -2 over x minus 2 cubed. Alright, now what do I do to both of these?
Set it over
Set them equal to 0.
Really just put the bottom.
Okay, so what am I going to get out of the first derivative?
Positive two.
+2, and what am I going to get out of the second derivative?
Positive.
+2. I'm going to get 2 out of both of them.
Which
But what do I already know about 2?
That's the asymptote.
It's an asymptote, so the only thing I can learn is what?
Increasing and decreasing.
And concavity. That's the only thing I can learn about it. So what does that tell me I do not have on this function?
Relative extreme.
Relative extremely good. So, on this first derivative, what do I know about this first derivative?
It's always positive.
It's always positive because I have x minus 2 squared. So that means both sides are positive. And what does that tell me about my function?
It's always increasing.
It's always increasing. Good. On my second derivative, number on the left would be 0. If I plug 0 into the bottom, it is negative, and the top is negative, so that means I am positive. A number on the right would be 3. Plug in 3 gives me and a negative on the top makes it negative. So what did I just learn about my function there?
It's concave.
Concave up on the left side, and it's concave down on the right side. So we know this function is always increasing and concave up on the left of 2 and concave down on the right of 2. Alright, so now we're ready for our sketch. What's the first thing I want to put on my sketch? The asymptotes, good. So x equals 2. And my vertical one is y equals -3. Gives me that. Alright, now what do I want to do? I want to find a couple points on the right of my vertical asymptote and a couple points on the left of my vertical asymptote is what I want to do. So let's do the left first. So let's find f of 0 and let's find f of 1. So if I plug in 0, that gives me 5 over -2, which is what?
Negative
2.5. Plug in 1. That gives me 5 minus 3 on the top, gives me 1 minus 2 on the bottom, which gives me 2 over -1, so that would be -2. All right, so what did we say was going on the left side of my vertical asymptote?
It was concave up.
Concave up and
increasing.
increasing. So I know this baby has to go that direction, and what does it do on the left? It levels off. All right, let's do the same thing on the other side. So let's find f of 3 and f of 4. All right, plug in 3. That would be 5 minus 9 and 1, so that's going to be -4. So 3 is -4. 1, 2, 3, 4. All right, plug in 4. So that is 5 minus 12. 4 on the bottom gives me 2, so that is -7 over 2, which is what? -3.5. So that would be about right there. Now, what's my function doing on the right side? Concave down and increasing. So it's going to level off there and go down there. Then it's always good to check your answer. And this is what it looks like. Does that match what we have graphed?
Yep.
Yes. So let's put a recap on curve sketching. If it's a rational function, I need to take care of what first? Asymptotes. After I have my asymptotes, I then want to do what? Take the first derivative and the second derivative. What do I get from the first derivative?
Your relative maximum and increasing decrease.
Relative extrema and increasing and decreasing. From the second derivative, I can find concavity and points of inflection. What has to happen at points of inflection? Change concavity. Okay? After I get everything that I have plotted, we always want to get an extra point on the left and an extra point on the right, and then we sketch it so that it matches everything we have written down. Any questions?